So, welcome, ladies and gentlemen. We're looking at last night's homework, page 296. Nope, 296. No, I was right. That was good. All right. Problem 18, we're talking about, it says, use the unit circle to find each value. So, 270-degree angle in the negative direction. You following along there, friend? Here's negative 270, right? So if I want to find a coterminal angle to that, I could simply add 360 to it, right? And I get the coterminal. And what is the coterminal angle? 90, right? And on the unit circle, what are the coordinates of this point? 0 and 1. And we said that cosine is the x value. So cosine of negative 270 is the same as cosine of 90 degrees.
And sine is y.
And sine is y, so that's right. So sine of 90, if it asked, would have equaled 1 for us.
Oops.
The answer was negative 1.
So why is it the x value? Why is it x and y values?
It relates to, I don't know if there's problems that are...
I didn't know.
I'll answer it when we're looking at the 22 problem set. I'll be able to better describe that. But it's related to drawing a triangle and overness and opposites and hypotenuses and things like that. So, how about one of these questions?
All of them.
How about,
Give me one.
Question.
how do you find, like, if for angles, like,
Can you do like
150,
22,
how do you
23,
know
24,
what the
25?
If I know just the angle?
Yeah.
Well, if it lands on one of the quadrantal spots, I can know those coordinates pretty well. But the other way around is a little bit different.
So cosine equals 1 and sine equals 0? Not necessarily.
No. Cosine is just whatever the x value is, and sine is whatever the y value is.
24.
24? 24 looks good. I like 24.
Can't remember that.
So let's look at 24.
I don't know. Are you sure?
So 315 degrees. I'm going to draw a picture here, even though I don't think it necessarily asked us. Well, but it's helpful. So 315 degrees. What quadrant's that in?
Fourth.
The fourth quadrant. Actually, that would land. Yeah. I asked this question. I heard the premise of this was kind of presented on a podcast I was listening to this morning. And in the Pac-Man universe, are ghosts dead Pac-Men? Yes. Wow, that's a really interesting point. It would be cannibalism. And then the other thing I thought was, if the ghosts are dead Pac-Man, then when Pac-Man eats them, eyeballs are a ghost's ghost. It's like a second-degree ghost. Right? And, right, so this, like, that doesn't make any sense. But if the ghosts are their own species, separate from Pac-Man, then are they really ghosts at all? Because isn't a ghost something that died and then became a ghost? And then even scarier, I don't think Pac-Man has a ghost when he dies. Because he just opens his jaw and dislocates it to the point of being like a snake and folds himself inside out into nothingness. Like, how terrifying is that?
That's weird.
Yeah.
Oh, it's like Hinduism.
So technically your whole statement was invalid.
Well, so I'm thinking that Pac-Man, when he dies, he's just dead forever. Because he just turned, like, he inside-outs himself until the whole world is his
And then
mouth.
Miss Pac-Man is just a imposter Mr. Pac-Man because she does the exact same thing. Just
Well, if that's just how their species die, then that's normal. But I'm saying they don't become ghosts when they die, right? But the ghosts might just be their own species, like some sort of like plasma-based species, you know?
Pac-Man is invading their home, eating all their stuff.
Whatever the dots
That's an
are.
interesting
What are
point.
the dots? Like who?
Pellets, and then power pellets are the large ones, which apparently disrupt the makeup molecularly of a ghost so that they can be eaten.
And then the eyes go back into like
The hideout.
cage, and
Yep.
then they just become more ghosts.
Yeah. Wow, so if you kill a ghost,
It just comes
it
back.
becomes a ghost again.
You can't kill a ghost.
You can put it
You
back.
just can't permanently kill a ghost.
Yeah, you can.
Well, anyways,
Like,
Bury them up. Bury the person up.
bury the
So-
person.
You like the bones.
You dig them up.
You dig them up. Put salt. Put oil.
Yeah, I like
Put
a
it
second
in
degree
there.
a second-degree ghost. Isn't that terrifying? Like,
Wait, okay, I have to
and then what happens, what if we found an even more powerful pellet that let Pac-Man eat the eyeballs?
Oh my gosh.
And then it would be like a third-degree ghost. The ghost of the eyeballs. So, anyways, I just thought of that because this is Pac-Man shaped right here. So, if I want to figure out what is the reference angle here, friends?
70.
I don't know how many
No,
cameras would be.
360.
Right, 45 degrees, which makes sense.
We got that reason.
Okay. Oh, no, there we go. So 45 degrees. Now, if I wanted to draw the triangle formed by this point, you didn't have to do this last night, necessarily.
You're right, I did it this morning.
Ba-dum ching. But here's my angle theta, so to speak. And if I want to find sine of, well, actually, so sine of 315 degrees.
Use your fingers.
Right. First of all, is sine positive or negative in this quadrant?
It's positive.
It's negative, that's the negative.
It's positive. The
Well,
two
think about-
left ones are negative. The two right ones are positive.
What the coordinates of this point would be, it's to the right, so the x coordinate's positive, and it's down, so the y coordinate's negative.
So sine is negative. Can't we still get the same answer? We did
We'll see.
315 minus 270, no cheats.
Well, that coincidentally happens to also equal 45. But that would be wrong because the reference angle is always measured to the x-axis, not the y-axis.
Yeah, you guys did it
Oh,
wrong.
okay.
You did it wrong.
So sine is negative. So sine of 315 is the same as negative sine of 45. And then we could do the hand trick and get root 2 over 2. All right?
Which equals what?
1.414-ish.
How do you get the... What's the square root
Wait,
of 2?
sine? Let's forget. So sine.
Oh, sorry. The square root of 2 is 1.414.
Sine's on
Root
this
2
side.
over 2 is 0.707.
How do you,
Got it.
how
Just
do you know
take the
that
wheel, guys.
sine 315 is negative sine of 45?
Because the reference angle is 45 degrees.
So
No.
the sine of anything is will be the negative
This-
sine of its reference angle.
It won't always necessarily be negative. It depends on which quadrant we were in. In the fourth quadrant, the y values are negative, so that's why the sine in any fourth quadrant would be negative. So,
Jesus, take the wheel.
Yeah.
so anyways,
Take it from my hand.
so cosine of 315 degrees, is cosine positive or negative in this quadrant? Positive. So that will be, you don't have to write this plus sign, I normally wouldn't, but just to emphasize. So that's the same as cosine of 45 degrees, and according to the hand trick, that is also root 2 over 2.
Yeah.
So anyway. Now,
Bang.
Wait, so if it's negative, then it's still root 2 over 2.
oh, sorry. Oh, this is a negative up here, isn't it? My bad. Because I said it was negative sine 45, but I never wrote the negative sign there.
Wait, how do you say how if it's negative or not?
Because where the quadrant is, if the y value is negative, then sine is negative in that quadrant. Right. So there's all sorts of little connections here that take a little while to get used to, for sure. Now, let us consider. Tangent, all right, is the ratio of y over x, we said yesterday.
Yeah.
Okay? So, well, actually, let me actually label these. So this is the square root of 2, this is negative square root of 2, and the hypotenuse is 2.
How do you know that?
Because if sine is opposite over hypotenuse, and it was negative root 2 over 2, from this angle's perspective, negative root 2 over 2.
Okay.
Although, I also could have called this...
Okay, just stop there.
Okay. All right.
Okay, friend. All right.
Okay. And cosine is adjacent over hypotenuse, so the adjacent is the root 2, the hypotenuse is 2. All right. So there's that possibility. Now, tangent from this angle's perspective would be what to what?
What to what?
Tangent is the ratio of what over what?
Isn't it?
Opposite over adjacent.
Opposite over adjacent. So negative root 2 over root 2 is just going to be equal to negative 1, is what tangent's going to end up equaling there. But we defined yesterday, we said tangent of theta is equal to y over x. And let me blow your minds just a little bit here. We said that sine of theta was equal to y. And we said cosine of theta is equal to x. So then if I substituted this in for y and this in for x, that means tan theta is equal to what? Sine over cosine. Dun, dun, dun.
What about their inverses?
Yeah, we'll get there. We'll get there. Inverses were just reciprocal functions is all we did there. But, so tangent, so check this out. Let me teach you some more hand tricks.
Boy.
Here we go. After this, I'm going to do some fingerboarding on camera. So here we go. Here we go. All right. All right. So tangent at 45 degrees. All right. I put this finger down. Sine of 45 degrees is root 2 over 2. Cosine of 45 degrees is root 2 over 2. Tangent, I just said a moment ago, is the ratio of sine over cosine.
Oh, it is? You said that?
Yep, I just did. I originally said it was y over x, and therefore it was sine over cosine. So tangent is the ratio of the square root of these fingers to the left divided by the square root of these fingers to the right. So it's the square root of the fingers to the left divided by the square root of the fingers to the right.
That's what tangent is?
Sine over cosine.
Oh, okay.
Why didn't you just tell us that yesterday?
That's what tangent is.
Because I'm teaching you now. So root 2 over root 2 is 1. All right, so I just want to point out that the hand trick also works for tangent. Let's consider tangent for this value.
So 30?
So 30 degrees, sine is root 1 over 2, or a half. Cosine is root 3 over 2. Tangent is root 1 over root 3, or 1 over the square root of 3, or root 3 over 3 if you rationalize that denominator.
How do you have to write that?
With rationalized denominators, if possible. So tangent, I just found out, so this is the same as tangent, it's green. So this is the same as tangent of 45 degrees. However, which we said was 1. However, let's consider the sign for a minute. Sign as in polarity, as in positive or negative. Tangent, I just said, is sine over cosine, or y over x. So if y is negative and x is positive, what is tangent going to be in the fourth quadrant? Negative divided by a positive is negative. So tangent is negative 1. Which is the same as if I just drew this triangle and I said opposite over adjacent, negative root 2 over 2, I also would have gotten negative 1 there. So let me ask this. When would tangent be positive? It would be positive when both sine and cosine are positive. Which quadrant would that be?
1. Or 2.
quadrant 1.
Or, yeah.
They're both positive. And since tangent is the ratio of sine over cosine, tangent would also be positive if both sine and cosine are negative. So which quadrant would that be? 3. So let me just draw a little...
I forget, like, which ones are
well, that's why it's always worth... If you remember this, you can just draw your points and figure out, okay, is the y-coordinate in this quadrant positive or negative? And just try to break it down that way. So let's see. So here's tan theta polarity. So tangent's positive here and here because both sine and cosine are positive here and both sine and cosine are negative here. And a negative divided by a negative is positive. And then tangent will be negative in these two quadrants because sine and cosine have different signs, SIG and S, in those quadrants. And dividing two different signs will give me a negative outcome.
Didn't we go on the chart of that yesterday?
We did it for sine and cosine yesterday. So, all right. So let's figure out what cosecant of 315 degrees is. Now, cosecant is just the reciprocal of sine. So it's just going to be, what's up?
Cosecant is the reciprocal of sine. Secant is the
Isn't that annoying?
Yeah.
Oh.
It's terrible.
Right?
What?
Literally, okay, so what she was just pointing out is cosecant's the reciprocal of sine, and secant is the reciprocal of cosine. I see C here, CC, and I'd want it to be the reciprocal of that. And I'm like, oh, it isn't? And then I see the S here, and I'd be like, oh, it's got to be the reciprocal of this. But it's not. It's the opposite of what you'd expect, and that's actually how I memorize it. I always remember it's the opposite of what I'd expect. And then I just make sure I never expect it to be the right thing. Yeah.
And then the reciprocal of tan is just... Right?
Yeah, cotangent. Yeah. So now in terms of polarity,
So that means cos should be 1 there, right? Because it'd be the opposite of -1.
the reciprocal, not the opposite. Now it turns out in terms of polarity or the signs of these values, if I flip negative root 2 over 2 and I flip it, it's still going to be negative. Okay? So these keep the signs of their counterparts. Right? So if I flip root 2 over 2, it's still going to be positive. Man, that was going to be a C there. And then I was like, S. I tricked it. It's pretty good. And cotangent is the reciprocal of tangent. If tangent's negative, flipping it's not going to change the sign. So that would be the same as negative cotan of 45 degrees. All right? So cosecant of 45 is just going to be negative 2 over root 2, which I believe ends up just equaling negative root 2 after I do a bunch of math to it. Math happened there. Secant of 45 degrees would just be 2 over root 2, which I believe just ends up equaling the square root of 2 after I do a bunch of math to that.
Oh my god.
And tangent, what's the reciprocal of negative 1? Negative 1.
What?
Or 1 over negative 1, which is also negative 1. All right. So yeah, so these are a little bit tricky. I don't think they needed you to necessarily figure all of this out. I think they would have allowed you to just kind of draw the picture and then just done the ratios of x to y's and blah, blah, blah.
So much stuff to remember.
It's all remembering the specific
Alright.
We'll go back.
Well, let's look at one more kind of problem. All right, this says, find the values of the 6 trigonometric. All right, what point should I do here? What number did we do? We went up to 31, right? 31's a little bit too 45 degree-ish, if I might say so myself. 32's a little bit too quadrantal.
39.
35.
Actually, 30's really cool. 30's really nice. Just the ratios that it'll end up having will be really nice for us.
What does Michelle Tan always say?
You got it, dude.
You got it.
So, okay, let's plot this point. Or we could Sean plot this point, right? If
Oh.
you're a Day 9 fan, his name is Sean Plot, professional StarCraft player. He also has like 590 Day 9 dailies right now on YouTube. It's pretty impressive. He's also a math major. Big fan. So, 1, 2, 3, 4. 1, 2, 3, 4. So here's my point. -4, -3 is right here. So let's draw this triangle, friends.
Does it always have to touch the x-axis?
Yeah, it goes to the x-axis. So let's label our dimensions. If this is -4, comma -3, what the overness here is -4. The overness here is -3. Question: what is the length of the hypotenuse?
Oh, isn't it? I don't know.
I'll be honest.
I don't know.
Well,
-4 squared plus -3 squared. So 25, so it's
yeah. So the hypotenuse is 5.
Hey, good job, kid. Add a kid. Add a
So,
Oh.
okay.
You said add a girl or something.
Attica? I don't know.
That's your name your next baby.
Anakin.
I think I'm done though. with babies. I was thinking of Anakin as well. Yeah. Sine of theta. Now these ones. Now that I actually once I have this x comma y, I could have just directly used this little table that I gave us yesterday. We wrote our own, but we had the ratios of all of these. Actually, did I ever get to the reciprocal functions? I don't remember.
What if you named your kid
Oh.
Vader?
Anyways, sine of theta, opposite over hypotenuse would be 3/4. Well, -3 over -4, which becomes 3/4. Nope, I lied.
There's a file.
3/5. My bad. 3/5. Hypotenuse 5. Yep, good call. -3/5. Darn it. Because now the minus signs don't cancel out.
Why isn't it just -3?
Opposite over hypotenuse, right?
That's the y.
That is true in a unit circle.
Oh, this isn't. Okay.
Because this radius is 5.
Okay.
Yeah, so sine is equal to y over r. Is what it was for a non-unit circle. And notice we did expect sine to be negative in that quadrant. Cosine of theta. Adjacent over hypotenuse, so -4/5. Right? Or I could have thought of it as x over the radius. Okay? Tangent would be -3 over -4,
Okay. I like this stuff better.
which is 3/4. Or I could have thought tangent is the ratio of y over x, which we talked about just a moment ago. Tangent is also the ratio of sine over cosine. Let's see, alternate method. Would -3/5 over -4/5 simplify to be the same thing?
Yeah.
Right? Because the minus signs, the 5s, I'd get 3/4 still. So I just want to point out, notice that is also equal to sine over cosine. There's just so many relationships between many different things here. Right? Thinking of this triangle, think of it in terms of x and y, thinking of it in terms of sine over cosine. Lots of stuff going on. I'm not going to lie. Let's see. Oh, wrong color. Cosecant. Theta is equal to the reciprocal of sine, so that's -5/3. Secant theta, the reciprocal of -4/5, so that's -5/4. And cotangent, I'll just throw that down here, will be the reciprocal of 3/4, so that's 4/3. Yeah, because it's left 4, down 3. Right? And like I said, you could have technically, once you found the ordered pair, you could have done it without ever graphing and just used all of this information here, where you just found the radius using the formula, which is just the Pythagorean theorem, and then all of that stuff.
Yeah,
So-
I'm confused. I'm already lost.
Okay.
Nothing.
Well, anyways, friends,
No quiz.
I know.
goodbye, Internet, and don't eat your eyeballs.
Or drink Mountain Dew.